Good morning, good afternoon, and good evening. A friend gave me this Asus router with no power issue, so it doesn't turn on. The router is in pretty bad shape. You can see here the broken plastic, and here also. So I asked him if he had dropped it, and he said no, but the location of the router subjected it to daily sunlight. So I guess because of all the sun exposure, the plastic here became brittle. Anyway, this has been opened, so I think he tried to open it because he also included the screws. There are a bunch of screws here which he taped together, I guess, so he doesn't lose them. And so this has already been opened. I checked the buttons here and more cracked plastic here. Anyway, so this is what we're looking at. I'm going to start with the power adapter. This takes 19 volts, and I have it plugged in. You can see the multimeter up in the corner. Typically these are center positives, so I'll put the red probe inside. And as you can see, 19.3 stable volts. So I mean, this doesn't mean 100% that the adapter is okay. Maybe under load it doesn't work, but let's plug it in. And there's an on-off button right here next to it. So I'm going to press that and we'll look for some light here. Okay, I pressed it in. I see no sign of any lights. Nothing at all. Alright, let's go over the board, see if we can spot any obvious issues. We have one fuse there. Let's measure it quickly. Okay, it's okay. See all the resistors in there. Okay, one above it. I can check these after. Alright, so I checked if there's a short on the main input plug, and there was none. I've been probing around the various what I call the power rails. Here is what I found. I'm going to use a screw hole for the ground. So you can see the multimeter is in voltage DC up in the corner. This power rail here, or this inductor, nothing, zero. This inductor here on the right is giving almost 5 volts. And we have also an inductor right here. And this one is giving nothing, zero. Now on the other side, so here we have 3.3, and the one above it, nothing. And the small inductor here to the left, 1.2 2, almost 1.2 volts. So I don't know if the other power rails come on based on some action. Like first this has to happen before this turns on. I don't know. But I'm thinking the next step is I'm going to check for some shorts around the ones that don't have voltage. I'll remove power and then check for shorts, and I'll be back. I also maybe need to remove this here and see what components lie below it. Anyway, let me start with the short checking. Alright, so I didn't find any shorts. Let's go over the inductors. My probes are around 1 ohm. So we'll use this ground. This inductor here is very high value. It's coming down, but it's very high value in the kilo ohms. This one here, and this one was actually working. This is the 5-volt one. This one was not working, or was not giving voltage. 1 meg. Again, it's going down, but it's 1 meg. This one here on the left, 44 ohms, 44.7 ohms. Slightly low, but I don't think there's an issue there. And then on this side, we have 3, 1, 2, 3. This one, yeah, it's in the kilo ohms, 5 kilo ohm and going up. This one here, again, high kilo ohms. Okay, it's going down, up and down, up and down. Lots of kilo ohms. And then this small one here, 433 ohms. I think that's all the power rails. So nothing obvious. Well, I still haven't found anything. In the meantime, I removed this shield from this part here, did some checks, again didn't find anything interesting. I think I'm going to proceed to remove these 2 heat sinks, and below those are a couple of these covers here. So I'm going to remove those and let's see if we find something. I'm at a loss because I have limited knowledge of how this is supposed to work, and whether the missing voltages is actually something wrong with it, or that's how it's supposed to be. Alright, so I removed the heat sinks and the shields and did a bit of checks all around, and I found nothing. Here is a bit of a close-up for anyone. And as I stated before, I also removed the shield here and did some checking, and again didn't find anything. Now, one interesting thing that I found was on this side. There is a resistor this tiny resistor right there. We'll go under the microscope in a moment, and it's showing that it's shorted. Now, from what I know from the research I had done, that resistors typically fail open, not short, at least statistically speaking. The odds are that they fail open. So I don't know if this is just a low value resistor or whether it's actually a short. But you know, I measured all the resistors here because I don't know if it will show on the camera, kind of, yeah. If you notice, you have a bunch of yellowed LEDs, and these are the LEDs for, you know, power and WAN and LAN and all these things, and there's one for the 2.4 gigahertz and one for the 5 gigahertz. But you see 1, 2, 3, they're like yellowed, brown, yellowed, and this one also. And the other strange thing is I used my multimeter and I could get one of these to light up blue, solid blue. A couple of them were like dim blue, which is okay, I guess, but none of the yellowed ones came on at all using the multimeter. Anyway, let's go under the microscope and we'll do a bit of checking. Alright, let's take a few measurements. You'll see that's the power LED. And if we measure this resistor here, around 100 ohms. The one next to it, R5, this resistor here, again is around 100 ohms. There you go. Now this resistor below the R5 is the one, my multimeters, when I touch them together, they give about 0.3 ohms. Let me turn this thing back on. Okay. So let's measure this one resistor down here. As you can see, it's giving 0.3 ohms. So a dead short, 0.37, 0.36. Again, when I touch my probes, we get the same 0.36, 0.33, you know. So either that resistor is pretty much shorted, or what? Or it's a low value resistor. But why would they have? I really don't know. So I think I'm going to remove that resistor and measure it outside the circuit. Alright, I'm going to use some hot air and remove that resistor. Now I realize that in the process I'm probably going to damage that LED, but I don't really care at this point. Maybe I can find a replacement LED to put back in. And in any case, the person who gave me this device really doesn't want it back. He already bought a new one. He just gave it to me because he knows that I like to tinker with the electronics. So even if I ruin that LED, that's fine. I want to get that resistor out to test it out of circuit. Here we go, 400 degrees Celsius, 50% airflow. Alright, there is the resistor we removed, and let's hope I can measure it without it pinging off. There you go, 0.5, 0.4. So this resistor is shorted. Now, does that mean the device is fixed? I honestly don't believe so. Plug the power in. Yeah, no sign of life. Press the power button. No, still no sign of life. Let me check some voltages, see if it's still the same as before or whether something new has happened. So here, still getting the 3.3 volts. Still getting the 1.2. This one I don't think was giving anything. This is still 0. And the other side, this was giving 5 volts. Let's see. Still giving 5 volts. This was, I don't think was giving anything. Yeah. This last one, I don't think was giving anything. No. So nothing has changed. I spent many more hours on this, and here's what I discovered. I started with the following voltages at power rails A, B, and C. I then noticed that A and C use the same DC to DC converter chip. And since A was working and C wasn't, I decided to swap them. So the voltages became this, which was a positive result and seems to indicate that the converter chip is indeed faulty. Now the reason converter B went to 0 volts is because the input voltage of B comes from the output of the A converter. And since A's output became 0 after the chip swap, it means B has 0 input voltage. If I decide to order some FR9618 chips, I might revisit this video in the future. Unfortunately, this is going to be a no repair because I've reached the limit of my knowledge here. I wish I knew more so that I can pursue this further, but I don't. Anyway, I hope you enjoyed this video, and see you on the next one. Bye bye.